Okay, so in a chemical processing plant, liquid is pumped from an open tank through a 0.1 meter diameter vertical pipe. Okay, so given diameter pipe is 0.1 meter and into another open tank as shown below. So this is the keyword, the important keyword, open tank. Uh, this is open tank. So open tank mean that the pressure is exposed to the atmospheric pressure. So P1 equal to P2, and then uh, okay, so P1 equal to P2, and then a valve is located in the pipe, and the minor loss coefficient for the valve as a function of the valve setting is shown in figure B. Okay, this figure is given in order to obtain the loss coefficient for the valve. Okay, so for the 0% mean that valve is totally closed, and then 100% mean that the valve is open. Okay, so this is to obtain the KL, loss coefficient for the valve. The pump head capacity relationship is given by the equation HA equal to 52 minus 1.01 power of 10, sorry, 10 power of 3 Q square. Betul, Q square Q2. Okay, yeah, Q square. So given HA equal to 52.0 minus 1.01 Q square. Okay, in meter cube per second. Assume the friction factor F 0.2. So F, what is the function of the friction factor?
0.02.
0.02. So this friction factor is given, okay, so that you can find the major losses due to the friction, and then minor loss, and all minor losses except for the valve are negligible. In that, you just consider the minor losses for the valve. The fluid levels in the two tank can be assumed to remain constant. Okay, find A Q flow rate. Determine the flow rate with the valve open. Okay, so Q when valve is totally is open. Okay, and then B determine the required valve setting. Okay, percentage of to reduce the flow rate. Reduce to 50%. Okay. Okay. So this is the given data and question. What is the problem statement? Okay. So you have this system. Okay. So you have pump. Okay. Now you want to pump the water from this bottom pump. Sorry, tank to this top tank where the diameter, sorry, the elevation difference about 33 meter. Okay, the elevation difference is 33 meter. Okay, so first, in the question, the pump performance curve is given. So this equation HA equal to 52 minus 1.01 power of 10, sorry, 10 power of 3 Q square. Basically, this is known as pump performance curve. Okay, so this curve or this equation is given by the manufacturer. Okay, so it is given by the manufacturer. So now, based on our system, okay, so based on this system, okay, this system, okay, based on this system, we may come out with our own system equation. Okay, so how to come out with the system equation? So this can be solved. We need to find our system equation. Okay, so how to find the system equation? Let's say this is point 1 and then point 2. Okay, point 1 and point 2. Apa? Tak dengar? Tanya soalan ke? Tak.
Tak ada, sir.
Okay. P1 over rho G plus V1 squared over 2G plus Z1 plus HA ataupun HP equal nak guna HP ataupun HA head available for the pump, and then at point 2 P2 over rho G plus V2 squared over 2G plus Z2 plus all the losses. Okay, so now P1 and P2 sama sebab both open to the atmosphere, so P1 and P2 is can be cancelled out, and then V1 velocity at 1 and velocity at 2, very low velocity. Okay, so now you can get the head for the pump. So HP equal to Z2 minus Z1 plus HL. Betul? Okay, so now Z2 is the D3. Okay, 33. We start here, so this is the datum, so 0 plus sigma HL. Sigma HL kita ada major losses dengan minor losses. Betul?
Betul.
So major losses, macam mana kita punya equation?
FL over D
FL
over D
FLT
V square over 2D.
Okay, so minor losses
KL
K.
V square over 2G
over 2G. Okay, sama setuju?
Setuju.
Sir.
Okay. So now kita okay, so 33 plus with kita simplify this equation, major and minor losses, so that you akan dapat KL plus FL D V squared over 2G. Betul? So sekarang ni F is given, length ada. Length for the pipe is 30 meter,
Okay,
and then diameter for the pipe is also given. Now we need to find this KL. Okay, so KL, how to find this loss coefficient for the WAF? So kecil sangat ni. Based on this graph 100% open. So you dah buat apa? You dah buat apa? Sini 5. So lebih kurang 1 So KL at 100% ataupun fully open, the WAF is fully open, KL equal to 1.0.
Tak boleh buat kosong.
Ha?
Tak boleh consider kosong.
Tak, dia kat atas tu. Dia bukan betul-betul dekat ni.
So kira ada value lah.
Ada value. Sebab range dia besar ni, 0, 5, 10, maknanya memang ada value.
Okay.
So 33 plus with 1 F berapa ni? F 0. Tak bagi F
0.02. 0.02.
0.02 length berapa?
0.1.
Length berapa?
0.1.
30 meter length, diameter 0.1. And then V square over 2G. Since kita nak we want to set up the Q equation, so the system equation consists of Q in the system equation, so we just substitute V with Q. Okay, so now Q equal to AV. V basically equal to Q over A. Okay, so V equal to Q over A. Q A, how to find A? Pi D square over 4 multiply with 2G. Okay, so you akan dapat another equation H pump for the system equation, which is 33 plus berapa ni?
Sir. Dia punya V tu bukan kena kuasa 2 ke sir? V tu tadi sir, kuasa 2.
V kuasa 2? Oh sorry, betul-betul. This one ni kan kuasa 2, area pun perlu kuasa
2.
Okay, thank you.
So yang V tu dia ambil V1 ke V2?
Mana? Oh ni V not V1 and V2 because V is V inside the pipe. V inside this piping system, not V at 1. Okay, V1 and V2 is 0 because it is exposed to the very large surface area, so we assume velocity is very small. But now we are talking about velocity at point in this pipe. Okay,
so kalau dalam pipe tu V dia memang akan constant je lah.
yeah.
Oh, okay.
Saya tak ada calculator, tolong calculate.
Sir, ya, kalau yang K tu kan saya letak kosong, saya dapat jawapan. Tapi tak tahu lah, mungkin saya ada silap lagi kot.
Ya. K ni tak boleh kosong sebab dalam soalan pun dimention ada losses due to the WAF. Okay. Berapa dapat? Berapa?
Saya silap.
Ke depan ni berapa? Calculator saya hilang. Tak tahu kat mana. Susah lah ada scientific calculator. Berapa? Dah.
Sir, chat sir, tengok chat.
Chat. Jom. Sekejap.
Sir, kalau saya tengok soalan kan, dia cakap determine the flow rate with the valve wide open. Kalau dia cakap wide open tu kan 100%. 100% kan bukannya zero ke?
Tak zero, tengok besarkan besarkan graf. Kalau you tengok kecil memang nampak zero. You besarkan dia tak duduk kat zero dekat 1.
K memang tak boleh zero sir.
Tak boleh.
Oh.
Kalau zero
Oh.
mean that no losses.
Oh, so dia
Kalau-
macam
Kalau you tengok graf pun memang dia tak zero.
Tapi kalau ikut ayat yang soalan tu bagi, macam mana sir?
57 apa dia? 57
Yang dekat soalan dia kata negligible untuk apa sir?
untuk lain-lain. Dia kata kadang soalan tu dia cakap mana?
except for the valve.
Except for the valve. Yang lain semua lain eligible untuk apa kalau ada fitting, pipe fitting negligible. Tapi untuk valve tak boleh negligible. Kena consider.
Oh, okay. Alright.
57 apa dia? So,
5783.88. Lima tujuh lapan tiga poin lapan lapan.
Q square. Okay. So semua dapat ni?
Dapat.
Okay. So sekarang ni kita punya we want to find what is the value of flow rate Q when valve is open. Okay. So Q, kita nak cari Q macam mana? Kita samakan equation H A equal to H pump. Okay. So HA ni pump performance curve, variable pump head which is berapa ni? So you akan dapat Q. So berapa dapat Q?
So 529.
Zero point 0529.
Sir.
Sama?
Ya sir, betul sir. 0.0529.
Okay, so that was for A. Any question? Ada soalan?
Tak ada sir.
Okay, proceed to
Faham lah sir, faham.
okay, proceed to B. What is percentage of WAF? Okay, so that the flow rate is reduced to 50%. So ini macam mana? Kita punya Q B. Q reduced to 50%. Okay, so maknanya our new Q is 0.0529 meter cube per second divided by by 2, 50%.
Oh.
So equal to berapa ni?
Kosong 2645. 2645.
Okay, so this is our new Q. If we reduce the flow rate to 50%. So from this Q, we can determine head for this pump.
Guna 52 tolak dengan
Pump performance curve tu. Mana? H A equal to 52 minus 1.01
Q square
0.02645 square. So you will get HA.
.29.
Yep. .29 meter. Okay, so there is HA. But now the question asks you to find what is the required WAF, percentage of WAF setting. Mean that to find the percentage of WAF setting, you need to find KL, loss coefficient for the WAF. Okay, so now guna equation tadi mana? Okay, so
Sir,
ya,
nak tanya HA tu saya dapat lain lah.
berapa?
51.29.
Oh, lain.
Saya 51 tu.
Saya
Saya
salah.
dapat 51 je.
Saya salah tulis kan?
Ha.
Okey, kejap. 51.
Oh, saya silap
Saya
bagi
dapat
tahu
sama dengan
saya.
Sir.
5129 tu, 5129.
Macam ni Okay, so HA ataupun now you have the H equal to berapa ni? Kita punya system equation 33 tambah KL plus yang ni ulang balik FL mana FL D Q FLD and then Q tadi apa? Q square Q ni Q baru latest Q 0.02645 square and then area tadi kita square kan pi d square over 4 kali dengan 2 dikali dengan, so kita akan dapat KL, loss coefficient. HP equal to 51.29 meter. Okay, so solve for this equation and then you will come up with the KL. So try to find what is KL. So dapat apa KL?
Sedang mengira.
Macam mana?
Sedang mengira.
25.64 sir.
Orang lain sama 25.6. Lebih kurang 25.6 ataupun 26. Okay, so now based on this KL 25.6, you can plot this here 25, okay, 25 here, and then let's say 26. 25, 26 here. Okay. So, yang ni saya base kepada you punya answer dia 26. So, lebih kurang kat situ je. You punya percentage. So, lebih kurang berapa tu? 10, 15 di sini. Lebih kurang 12%. Kalau base kepada KL equal to 26. Okay, so based on okay, so lebih kurang 12%.
Sir, KL tu tak ada unit sir?